Hello everyone, let's start today's problem. So our today's problem is 221 lead code problem, which is the maximum square. In this problem, we need to find the largest square containing only ones and return its area, right? So we need to find the largest area containing only one, and it should be a square. Square means length and width should be same, right? So as we can see in this example, so here we can see the maximum square that contains only one having a size only 2, right? This one is a 2 by 2 square, this one is also a 2 by 2 square, right? And same here with 1 by 1 square. So in this problem, as we will move forward towards the DP problem, so DP in this problem there is only one small observation. If you get, then problem it's a piece of cake. So let's say I want, let's say this, I want to check, okay, till this here, like I want to check, let's say our matrix is this one only, till this cell, how much bigger square I have, like for this cell, how much larger square I have having a corner as this one, okay. So having a lower right corner at this cell, how much bigger it consists, like how much bigger is it's having a square. So for this one is one, so it can be this cell, okay, it is having this one. So this one is also fine, like having all those one. This one is also fine, right? Right corner is here and this one, but upper one no. Why? Because here it is a 0, right? So it can extend only this one, 2, okay. And same, I go through with this example only also. Same matrix, it can have this one, this one, but not upper one. So this is the maximum length it can have. And same with the third example also. If I want to stretch, these four can be in our answer having a lower edge, this one, this can be our answer, but not this one, right? So one small observation is that if I want to include the last layer in our square, right? This one is perfect square. If I want to add this one, so what is the flaw here? It should be one, okay. And as for this one also, it should be one. This one also, it should be one. So if I let's say just divide these three into three squares, right? As this cell, let's say connected with this cell and this cell. So what is the largest square consisting of the upper one having a this one as the lower corner, lower right corner, this square matrix. What is the second square matrix having this lower corner, which is just connected to this one, our desired one, this lower matrix. And same with the other one, this square matrix, right? So if we see that we cannot pass, if I want to include this one and find the maximum square, I cannot pass the minimal square, like I cannot pass go through this because this is the minimal square. Same with here, right? This one is the square, this one is the smaller one. Like if these three are there, so see the squares, this one is consisting this one, this one, this consists in this one, but for this one it is only this square because it cannot extend from there. So for this one is the minimal is this one. Same here, the minimal one, like for this one The adjacent one having the minimal matrix is this. So I cannot go beyond the size of the minimum adjacent squares. For that reason, if I want just know like this, okay. So for this, you can see like this is the red one. Here, this is the blue one. Okay. These two are the squares, perfectly square matrix. And third one is also a perfectly square matrix. Now, what I want to make a square like here and bigger one. Like if I want to include this length also, like is one, this should be also one. But here there is no one. Here is only one, only this thing. So the square can only be extend till here only. This could be the square. Okay. Okay, I know this is looking like a rectangle, but I hope you understood, right? uh, Main thing is that we need to find the minimum square adjacent to that cell. Whatever is the minimum square adjacent to that cell, uh, it's the just one bigger cell is our answer. So we will define a dp matrix, and our dp state will be the maximum length of a square containing one, right? So our dp state will be minimum of dp of I minus 1 j minus 1. These are the adjacent cell, right? So I minus 1 j minus 1, if this is ij, this is I minus 1 j, this is I j minus 1, this is I minus 1 j minus 1. Okay. So our dp matrix is nothing but the minimum of these three values plus these three values plus 1. Okay. So this is the only solution that we have to implement. Now let's go to the code. We will start coding. So I hope you understand this. Yeah, we want to fill this cell. For this cell, we will check the adjacent layers, adjacent cells, this one, and whatever is the minimum square having at rightmost lower edge as these cells, whatever is the minimum, we can extend only that to a bigger one. Like let's just expand this square to a bigger one. That will be our answer. Okay. And here just expand, this is the thing, right? They expand this square to a bigger one. This is our answer. And for this one, right, just expand this one, smaller one. This will be our answer. So just a bigger value of minimum one. Okay. And our dp state is nothing but the minimum of the adjacent lengths, and just adding one is our answer. So let's go towards the code. Code is simple if we understand that thing. So we will just make a vector of vector of int as our dp of size. This is, let's have this thing, right? Int n equals to matrix size, and m equals to mat. Here this is the column length, this is the upper one is the row length. Vector int m, and let's start with the 0. Okay, this is the length. So at start, each length is the 0. And now I want to initialize one thing. Simple is that the starting points, right? I want to start how I started. So for the corner values, if you see these corner values, no matter how long this one is, like how long this chain is, the square could only one for these corner values, right, which are at the edges, starting one, like row 0 and column 0. No matter how long this one could be, but the square made by these cells larger, it could be one only, right? It cannot be more than one. So we need to fill this at the start. So I hope you understand, like we want to add up and just made it like one size larger. Okay, now let's do that, whatever I have said. If matrix 0 0 is equals to this is a string, I think, 1. Let's make answer int answer equals to 1. Then dp of 0 0. What is our dp? Is the maximum containing maximum length having of a square as the edge on the lowest right corner. Like if this, for this one, it is 2 only. Okay, so lower right edge is this one, and it consists of this square. So it could be only one here, and here answer is also one. Okay, so this one is for the 0 0. Now we can have a for loop less than n I plus plus. So same thing. If matrix, so this is the row only, right? So zeroth column and each row, zeroth column and each row, this one. For we are traversing at this one, it should be dp of 0. Okay, okay, 0 0 1 I 0 1, no problem till here. Same thing with the column also, like this one is this. Now just traverse. We previously traverse here, now we will traverse at 0th row. So for this one, just make it m. I know it's not good, but not that much fast, right? Okay, and this is 1, and this. Now the final thing, as we are filling our dp from the bottom up, like for a uh, each value we need the previous values, right, from here, and so we will traverse through 0 only. Same thing, if matrix of I, j, what we need to do, we need to do nothing. dp of ij is nothing but the minimum of dp of I minus 1 j minus 1 comma dp of I minus 1 j dp of I j minus 1, and okay, and here it is plus 1, right? We need to add plus 1. Here was our answer, so this answer should be updating like whenever we find one. Okay, no problem with that. And it could be answer nothing but the maximum of answer comma this one TP of A. So it is just telling you whatever the maximum length it should have that one for each row and those things. Now return the area of a square, and this is should be our answer. Let's see if it is working or not. Okay, there are some issues. Matrix of 0, comma 0. It is character, right? Not a string. So these type of error could be happen, no problem, right? Okay. Small silly mistakes. Rest is fine, I think. Okay. It is given here. It is a vector of character, not a string. Now this one is working. This one is not working. Okay, we have 0 right here. We are returning answer into answer. Till here it is good. Is the problem. Mm, my output is 1 and expected is 0. Okay, these should we start from 1 now, because we have already covered this here 0 comma 0. So initiation for this cell 0 comma 0 is already there. Now and here 1 comma 1, let's see, 1 0 y 0 0 I 1. What is this thing? Wait, this is good, this is also good. 0 0 answer equals to 1. 1 2 n minus 1 I this अगर 1 है तो I 0 0 ठीक है. Now हम 1 से ही स्टार्ट किया, m से नीचे m, नो प्रॉब्लम. पहला n था, सेकंड m था. I प्लस अगर ये मेरा 1 के बराबर है तो ये 1 हो गया, आंसर 1 हो गया. आंसर को हम लोग 0 से इनिशिएट करेंगे. Yeah, okay. So here it is our answer and everything is fine. I hope you like the solution.